polynomial functions. So experts fear that without conservation, A4 tiger could disappear from the wild by 2022. Just 100 years ago, there were at least 100,000 wild tigers. By 2010, the estimated world tiger population was 3,200. The bar graph shows the estimated world tiger population for selected years from 1970 through 2010. Also shown is a polynomial function in the right side here, with a graph that models the data, use the information to solve the exercise. So now here, this is the graph that is estimated from 1970 to 2010, and this graph here, it signifies the decrease of population of the tigers from 1970 to 2010. You see, and further. So 0 is 1970, 10 is 1980, 20 is 1990, 30 is 2000, and 40 is 2010. So that's, and it can continue further. So now let's try and answer some questions here. What we have? Find and interpret f of 10. Identify this information as a point of the graph of f. We already said this is a f of 10 is going to be here, and it means it's 1980. We want to see for this 1980 how many tigers there were by calculating in this function. Let's see what the function tells us. So now let's take a pen, and we are plugging in f of 10. So we already have the function here. The function is here, but instead of the x, we are plugging 10 because we want to know in 1980 how many tigers there were. Do they give this the right number? So here is a 0.76, and whenever is this 10, let me write in a cubic. So 10 is a cubic, and is a minus 30. Instead of the x squared, I am plugging here 10. And let me continue with this number here, minus 882, 882 times 10. And the last number is 37,807. So 37,807. Now let me squeeze this number here, 87. And now we are calculating here. For example, 0.76, but 10 cubic is 1000, times 76 is 760. So I think this is easy to calculate with this number, but this is a square, because here I forgot to write square, and 10 squared is 100, times 30 is 3000. So we have a 3000 here. And now minus 882 times 10, this is easy, so we are adding just one extra 0, and so we didn't need to use a calculator. Plus we have a 37,807. But now those are big numbers. We like it or not, we have to use a calculator here in this case. And the calculator shows us this number here. Let me bring it here. Oh, here, okay. So 37,807 is minus 8,020, and is a minus 3,000, and is a plus 760. 760. And the number is 26,747. 26,747. 747. So according to this function that models the decrease of population of tigers, it says in 1980 can be 26,747 tigers. But let's see here what is in 1980. But 1980, according to the estimation of the data here, is 28,000 tigers. There were actually 28,000. So now let's say here in 1980, Let me write it with a different color. According to the graph, there were 28,000. However, the function here gave us this number 26,747. That's what they gave us. And now we are looking, does f of 10 overestimates or underestimate the actual data shown by the graph? By how much? It means this underestimates because the graph, in the graph we already saw, actual graph says is 28,000 tigers, but the function gave by 26 is less than the actual data, is 26,747, but it says by how much, and it's by how much we need this to calculate. How we can calculate this? Let's make this a minus number, right? I'm sorry, this minus here, and the plus 28,000. 28,000. And we get by 1,253. So it underestimates by 1,253. So this number is a minus of the actual data. So for 1,253 tigers less, it shows. And now in the C we have use the leading coefficient test to determine the end behavior of the right for the graph of f. So in the right side we want to know, but let's try both of them. This is a cubic function and leading coefficient is a positive. If a leading coefficient, let's say a, is greater than 0, so this is a leading coefficient, and the function is odd function, it means the function is going to go in this way. This is the graph of the function, how it can look approximately or usually. It means the behavior of the function as x goes to infinity, to negative infinity, I'm sorry, f of x goes to negative infinity. We already see here f of x tends to go to negative infinity. And same thing now, if f of x goes to positive infinity, so x goes to positive infinity on the right side, that's what they are asking, f of x, the end behavior of the function f of x is going to positive infinity. So it goes to positive infinity. So to the right side of the graph, it goes to the positive infinity. And it says, might this function be useful in modeling the wild tiger population if a conservation efforts to save wild tigers are successful? This function, as we see here, it's tending to go to infinity. And if we go here, for example, at any point it's going to go up, and it's go to infinity. Maybe for a certain period with a restricted domain for a few years, it can be useful, but after 10 years or 20 years, it won't be very useful. For example, if we are graphing this data in the Desmos, we have this kind of the function here. Let's see, here is a 40, we said it's 2010. Every 10 units is a 10 year. Here is a 2000, let me see just one more time here in the data. 2010 is in a 40. And let's go back. 2010 in a 50. 2020 or 2030, I think here is in a 60. And as we see in a few years, in 10 or 20 years, is going to increase very quickly. So for a restricted domain, it can be useful, but it cannot be useful for a long period of time. Maybe for 5 to 10 years, if we wanted to have some balance in nature, we can use it, but not for a long period of time.